Good morning. My name is Chris Jerrier. Good morning, Mayor. This is David and Joseph, who will only be reading a paragraph today because he has a slight cough. So here's David with what is nuclear energy?
What is nuclear energy? Nuclear power is the use of sustained exothermic nuclear processes to generate heat and electricity. The term includes the use of exothermic nuclear fission, nuclear decay, and nuclear fission reactions. Presently, the nuclear fission of elements in the Decay series of periodic table produce the vast majority of nuclear power in service of humankind. With nuclear decay processes primarily in a form of geothermal energy and radioisotopic thermoelectric generators being the other two major uses of clean and sustainable energy resource. Types of nuclear reactions, Chris.
Thanks, David. So how does nuclear power work? Types of nuclear reactions. Fission. Nuclear fission occurs when an isotope of a radioactive element becomes unstable, causing the entirety of the atom to literally split, usually into three or more smaller, lighter nuclei, those of which are different isotopes of the element than before. Fission of radioactive elements is the most prominent and used source of nuclear energy we have today. Radioactive decay is the actual radioactive process by which an unstable nucleus in the atom of a radioactive element gives off radiation. For example, uranium-238, a moderately radioactive element, is only dangerous because of how heavy the element is, meaning the atoms have an unstable electron configuration. To gain stability, it must either bond with another element of equal instability, nuclear fusion, or decay, nuclear fission, and give off dangerous radioactive gamma rays. Fusion, on the other hand, is the process in which two atoms of completely different elements combine and fuse. Though humans have not been able to harness the power of the sun, we witness it every day when we look up into the sky. The sun fuses the elements of hydrogen and helium to produce its energy and does so by colliding the two atoms at extreme speeds, temperature, and pressure, causing the two atoms to become a new nucleus, that of which is used as fuel for the sun. Nuclear fusion produces extreme heat and radiation and would provide large, copious amounts of energy for thousands of years if we were to be able to harness it. Here's David with the process of nuclear power.
Okay, the process of nuclear power. Nuclear fission.
Okay, hold on. There we go.
The process of nuclear power. Nuclear fission is undoubtedly the most common use of nuclear power. Very similar to the use of burning fossil fuels in the sense that coal and oil are burned. The thermal energy from nucleus splitting provides heat to create steam, ultimately spinning a turbine which then processes electricity, safe, clean, and effective. The theoretical process of harnessing raw energy from nuclear fission would include an atom of uranium to be placed on a pedestal inside of a sealed and safe nuclear containment reactor casing. A neutron gun would then be positioned pointing towards the sample, which would then fire one single neutron of equally unbalanced material, such as plutonium, at a very high speed. The collision would likely cause atoms of the uranium to split and eventually cause a chain reaction. The thermal and raw energy from this chain reaction could be used to scale a tenfold to common process of fission reactions. Here's Chris with nuclear.
Sorry. Okay, so how do we use nuclear power? Worldwide, approximately 13.35% of all power comes from nuclear energy. In the United States, however, that number is much smaller. Very little of the energy that we use derives from nuclear sources, ranging from only 5 to 9%. My bad. A 10-gram pellet of uranium can power a city the size of Lincoln City for 5 days. 5 days compared to 1 ton of coal, 149,000 gallons of gasoline, or 17,000 cubic feet of natural gas. Here's Joseph with some of the benefits of nuclear energy.
Reduced emissions, there are virtually zero harmful emissions put out from the process of providing and making nuclear energy. The only two byproducts of this power energy sources, one more of the risk than the other, is steam and spent radioactive waste. Safe, effective, by far, nuclear energy is the safest, cleanest energy resource we have today. If certain protocols and regulations are set for the disposal of nuclear waste, we are set for the future. We are addicted to oil, converting to many of these alternative energies, including nuclear, wind, and hydroelectric. It would boost the economy because of how self-sufficient Americans would become. It would create jobs at plants. It is completely safe and environmentally friendly. And here's the risks of power energy with Chris.
Thank you. So what are some of the risks? One risk is obvious. Radiation comes from everything and affects us in more ways than you may know. But actually, you absorb more radiation from eating one banana than you do living within 50 miles of a nuclear power plant for a year. However, ionizing radiation can be very harmful to living cells. Although the radiation levels may vary, standing in one spot on the site of the Chernobyl accident will give you 6 millisieverts of radiation, 1/6 of what is needed to cause radiation sickness. Accidents can always happen. The odds, however, of an accident occurring are very slim. There is only a chance of 1 in 5,380 of possible human error, and 1 in nearly 300,000 possibility of technological error. Accidents like Chernobyl and 3 Mile Island were caused by operator error. So, I have to warn you, some of the following images may be graphic. On the left, you'll see that the fellow has suffered from severe atomic poisoning. He has yellow skin, holes. He suffers from extreme brain trauma and hyperactiveness. Thank you. And then the thing on the right, I actually don't know what that is. I kind of just got it off Google Images. So, and yeah, you're supposed to laugh, but it wasn't funny. All right. And yeah, that's nuclear power.
Hello, I'm Harley Ernst. I'm doing nuclear energy for Mr. Rasmussen's Integrated Science third period class with Taylor Johnson and Ian. Get down here. With Ian Etheridge. Apparently he's not coming up. And this is nuclear energy. And
So some of the benefits for nuclear energy is more efficient and traditional energy sources. A single kilogram of uranium can produce the same energy as 200 barrels of oil. Some of the downfalls are radioactivity with like waste and stuff. And forgot what else.
how nuclear energy works is the splitting of a uranium atom, and the energy from that atom split heats up water, and steam spins a turbine, and creates electrical energy between coils. And the only emission that nuclear energy has is water vapor from the tops of the billows, and that's about it.
Nuclear Energy by Canyon Jackson, Joshua Wright, Michaela Martin. Currently nuclear energy occurs for about 1/3 of the world's power in France and Lithuania. However, it occurs for about 75% of their power. Nuclear energy has little waste, almost no pollution, and is very efficient, making it a great power source.
Nuclear energy is much like a coal power plant. The only real difference is that the heat comes from uranium nuclear fission instead of fossil fuels. The controlled nuclear fission heats up water, which is then converted into high pressure steam. The steam then turns a turbine, which is hooked up to a generator that creates electricity. Steam is then either let out through cooling towers or is recycled to be used again. Yeah, that's just pretty much how it all looks. Nuclear energy is basically one of the most efficient sources for power that we know of. If the same amount of electricity being produced by nuclear energy was to be produced by fossil fuels such as coal, it would emit nearly 147 million metric tons of carbon dioxide, which is about 3,675,000 semi-truckloads. And a nuclear power plant only has to refuel about every 2 years, and usually only 1/3 of the fuel runs.
Surprisingly, since the nuclear industry began, the amount of waste made is only about as big as a football field, and it is about 15 yards deep. This is extremely more efficient than fossil fuels and is much less polluting. This waste can be easily managed by containing under site or in repositories. For France and its 58 nuclear power sites, the whole country has only 3 repositories, so it is very well handled. We hope that you will now consider nuclear energy a reliable energy source.